Waiting, 7 p.m. Julie is here. Cool. People already chatting. People start chatting. Is that we go live already? Live? Yes, we're live.
We're live?
Yeah, we're live. Let's
Yeah.
take 5 seconds or 10 seconds to start off.
Yep.
So we got already one comment from Julie with the good vibes in it. I think it's hello to Vijay.
Hi, Julie.
All right. Anyway, so we're about to start. 1, 2, 3. All right. Hello and welcome to night class. My name is Andre, and with my partner in crime is Vijay. We are a consultant from Zenika. We are a tech consultant firm here in Singapore who provides technical expertise and trainings. So right now, the event is running Spark workloads on Amazon EMR with Vijay. And a little bit about our company. Zenika provides the expertise to build the high-performing teams, enabling the production of sustainable IT products. We provide some of the service like a product engineering, training courses, and practicing consulting. And our vision, the most important, what we believe in, is coding the world. Here's the dramatic pause for us. And few words about the organization of this event. This session will be around 1 hour. And if you are trying to stay on a topic, you can stay at the end. We can discuss some of it. You can actually ask questions in the comments below here, since we are streaming live. And we about to answer them by the end of the session. So this is even going to be recorded and will be displayed on YouTube later. This is a good time for hit the likes and subscribe button if you don't want to miss anything. If you want to leave for any reason, you can go here and later watch this anytime. So Vijay is going to present the 7th theme. And meanwhile, please ask the question and comments. We'll gather them together. And by the end of this session, he will be answering them in Q&A. So a few things. Please say hello in chat since you're online. And it will be nice to see who is attending to this session. And if there's any question, don't hesitate to answer or participate in discussions in the comments. So I'll pass this mic to Vijay, where he will introduce himself.
Hello, everyone. Thanks for joining the session today. I'm Vijay Nathari, consultant at Zenika Singapore. I'm having expertise in AWS Cloud and Big Data Analytics. I help organizations to migrate the workloads to AWS Cloud. So currently, many organizations are trying to move their big data workloads to Amazon Cloud. So organizations are doing this to reduce the cost of maintaining the servers at their on-premise location and get the scalability and the flexibility which cloud provides. So in this process, organizations are facing the cloud skill set problem, where they wanted to understand how these workloads will be run on AWS Cloud. So the main agenda of today's session is to help the organizations and developers to understand how big data workloads can be run in AWS Cloud using Amazon EMR. So the agenda we are having in two parts. So first half of the session, we will discuss about what is Amazon EMR and its architecture and the benefits it is going to give to the organization. The second half of this session, we will be running a live demo to understand what kind of benefits it provides with a real-time scenario. So in this demo, we'll be doing a step-by-step execution of the Spark job. And after this demo, we will be sharing you the code which we have used for this demo. And you can try it at the end of this session, you can try it on your own AWS Cloud. So throughout the session, if you have any questions, you can put it in a comment section in this YouTube channel. We will address that in a Q&A session. So before going into what is Amazon EMR, let's try to understand what is AWS Cloud for the people who are new to it. So AWS is the cloud service provider which offers reliable, scalable, and inexpensive cloud computing services. It is present in 25 geographical regions around the world, and it spans across 81 availability zones. So it has 200 plus services, which is broadly categorized into compute, storage, database, network, and content delivery, analytics, and so on. The service which we are going to discuss today falls broadly under the analytical category. So if you take any data analytic pipeline, it will be having the stages as shown in this diagram. So for each stage, AWS provides a set of services. So you can see under these stages, it is listed here. So right now our EMR service falls under data processing stage. So it is used for the data processing. So let's start. What is EMR? So Amazon EMR. Amazon EMR is an elastic MapReduce service, which is used to run big data workloads in AWS Cloud. It supports big data frameworks such as Apache Hadoop and Apache Spark. It is mainly used for processing and analyzing the vast amounts of data, and also transforming and moving large amounts of data in and out of data stores like S3 and databases like DynamoDB. Amazon EMR cluster is a collection of EC2 instances as shown in this diagram here. So each instance in this cluster is represented as node. So it will consist of three main nodes. So first one is the master node, which is responsible for managing the cluster and distributing the data and the tasks across these nodes. So core node is responsible for running the tasks and also storing the data in HDFS file system. The last one is the task node, which is optional in the cluster, which only runs the task. It won't store the data. In case you want to increase the compute capability to your cluster, you can add as many task nodes as possible. So the use cases where Amazon EMR service will be useful are running the ETL jobs, machine learning jobs, interactive analytics, and clickstream analysis. So today we are going to run a Spark job in Amazon EMR service. So let's touch upon what is Amazon Apache Spark for the people who are new to it. So Apache Spark is a data processing framework which is used to run the big data workloads. It gained the popularity in the market because it uses in-memory caching capability and also optimizes the query execution plan for its big data workloads. Spark cluster consists of three main components. Driver program, where your Spark code starts here and maintains the cluster context here. And the cluster manager, which is responsible for acquiring the resources and allocating them to the Spark jobs. Worker node, which is where the actual Spark code will get executed. So it has executors. Each executor will execute the task. So this task will return the result back to the driver program. So the worker node also, the executors also maintains the in-memory caching of RDDs. So let's look at the benefits. So Spark is fast. It is 100 times faster than the MapReduce framework and 10 times faster storage than the HDF Hadoop file system. And it is developer friendly and it can run multiple workloads. Let's see that in the next slide where we will discuss about Apache framework. So Apache framework consists a rich set of libraries, so which can run multiple jobs like machine learning jobs, real-time analytics, interactive queries, and graph processing. So these libraries will sit on top of the Spark core, which is responsible for memory management and fault tolerance and scheduling and monitoring of the jobs. So the Spark core will be exposed as an API written in multiple languages like R, Python, Scala, and Java. So that's why it is developer friendly. Developer can choose the language which is comfortable in it. So in today's demo, we are going to run a Spark job, which is written in Python language, and we'll use the SQL for it. So let's check in the next slide how this Spark framework fits in the EMR architecture. So EMR architecture consists of four main layers as shown in the diagram left side. So each layer will be having some capability which will bring it to the cluster. So let's start with the bottom to up. So let's start with the storage layer. So storage layer is responsible for storing your input and output data. So it provides multiple file systems like HDFS or EMRFS, which is nothing but S3. So you have a choice to choose between these two. And the cluster resource management layer, which is responsible for acquiring the resources and allocating them to the jobs. So by default, EMR uses YARN, yet another resource negotiator. So because of this YARN, it will support multiple data processing frameworks. And you can see in the third layer, it supports Spark and MapReduce and Page and so on. So if you use a data processing framework like Spark, you have in the fourth layer applications and programs which you can use on top of it, like Spark Streaming, Spark SQL, and so on. So right now in our demo, in the coming demo, we will be using Spark SQL to analyze the data, input data, which will run it on the data processing framework like Spark and uses the YARN. And the storage, we will be using EMRFS. So as we are using storage as EMRFS, let's talk about it and know more about it and what benefits it brings in the next slide. So what is EMRFS? EMRFS is a EMR file system, which is similar to the Hadoop file system, where EMR cluster can read and write the files directly to the Amazon S3. So S3 is an object storage service, with which you can store any amount of data in it. So AWS will take care of scalability, data availability, security, and performance for you. So EMRFS provides many benefits as shown in this slide. So most of these benefits are native S3 benefits. So except the S3 optimized committer, which is used to write the output of your job to the S3 in an optimized way. And it uses the multi-part uploads where it will split the data. If your output data is huge, it will split the data and writes it to the S3. So S3 select is used if you have an input data which is very huge and your job requires only subset of that data. S3 select is the best option. What it does is it filters the data at S3 level only, so that only the subset of data is transferred to the Amazon cluster. So encryption also you can use to secure your data. So server-side encryption and client-side encryption also possible. So in case you want to reduce the cost of storage, you can use the lifecycle rules where you can move the infrequently accessed data to different storage class, which is cheaper. Replication rules will be useful when you have a disaster recovery in place. So what it does is it will copy the S3 bucket data from one region to another bucket in the another region, so that if any disaster happens in one region, you can just spin up the cluster in another region and use the data in that bucket. So let's continue to the next. And let's see the benefits of the EMR now. So how it is benefiting the organizations. So the first one is the cost saving. So you don't have to maintain the servers or you don't have to buy the servers. You just pay as you use. So scalability and flexibility. So in case you want to scale in and scale out your cluster according to the load, you can do that using auto scaling, and you can even do a manual resizing as well. It provides a flexibility for you to install the softwares on it, and on your own softwares also you can install, as well as it will provide you to use a on-demand and spot instances together to save the money. As discussed in the previous slides, like you can use a HDFS or EMRFS. That flexibility also it gives. Reliability, in case any node fails in the cluster, it will automatically replace that node with the healthy node. Security, you can spin up the cluster in VPC to make it private and give the permissions using IAM role, encrypt the data in S3, in transit and at rest, and use the EC2 key pairs to SSH into cluster, or else the Kerberos authentication also supported here. And CloudWatch metrics are used for monitoring the performance of the EMR cluster. You have a multiple deployment options also. You can run the cluster in EC2 instances, which we are going to do it in our demo. Or else you can run it in a Kubernetes cluster or at on-premise server using AWS Outposts. So there are rich set of management interfaces which it will provide. So you can use any of these interfaces to interact with your cluster and manage your cluster. So right now in our demo, we are going to use the console, EMR console, so through which we are going to run our job. If you are admin, you wanted to run the commands, you can use the CLI. And in case you want to build a custom application to spin up the cluster, you can use SDKs and also web service APIs. So it also provides the AWS integration, which means it interacts with the other services as discussed previously, like S3, Cloud, CloudWatch, CloudTrial, like that. So we have discussed about the benefits of EMR service now. So let's see how in the real world scenario, these will be helpful to the organizations by running a live demo. So in our live demo, we will be having this set of steps. So first, we will create the EMR cluster. Later, we will copy the data, the input data, and also the script file to the S3 bucket. So we'll discuss about the S3 bucket structure also, how you have to keep the input folders and all. After that, we will run the Spark job using EMR step execution, which we are going to discuss there. And next, we can monitor the Spark job using a Spark history server, which EMR provides. After that, we can verify the results using Athena. Athena is a service to interactively query on the data present in S3. At the end, we will terminate the data, terminate the EMR cluster manually. So all these things, we will be doing it manually. So at the end, we will automate these processes using orchestration service like step functions, which will orchestrate our job. And we will schedule the job using Event Bridge. So let's see the service architecture, what we are going to do in cloud. So this is the architecture. So the services which we are going to use, we will spin up EMR cluster. It picks up the input data which is present in S3, processes it, and then writes back to the S3. So after writing back to the S3 on the output folder, we will run queries using the Athena. Athena is used for querying on S3 data. So using a glue catalog. So glue catalog acts as a schema for that file present in S3. So now let's pin up the cluster first. So let me share my window. Okay. First, log into the AWS Management Console using the IAM user, which has permissions to execute the EMR service. So type the EMR service, click on it. And before creating the cluster, make sure that you selected the proper region. So I'm selecting the US East 1 region, default one. You can choose whatever region you want. Create the cluster. Give the cluster name some meaningful name, like Spark cluster -demo. So So to debug, if any issues comes in the cluster, so it provides the logging facility. So all the log files will be logged to a single location. So this is the default location which AWS provides. So it creates the folder structure like this in your account. But we wanted to use a different folder, so that we can do it by creating a new folder. Let's go and create a S3 bucket, new S3 bucket to hold the logs. Type S3. And click on create bucket and give the bucket name some meaningful name, RemoteClazz. And make sure that this name is unique, because it should be unique across the globe. Otherwise, it won't let you to create. So, and choose the region which is same as your EMR cluster to access the data. And rest all, you can keep it default and create the bucket. So search for the bucket which we created. So in this, we can hold the data right now. So in case you wanted to hold any data, first you have to create a bucket and also create a folder if you want to organize the data. So let's create the folder. So we'll be creating a log folder. So give this path in the cluster creation here. Select the path here. Bucket name and the folder name. Select. It's done. Now the launch mode. So EMR cluster provides a facility to run a long running cluster as well as the transient cluster. So long running cluster, if you create, it will run 24/7. And if you want to create only for one step execution, that means you wanted to run one job and terminate the cluster, that you can do it with step execution. So it consists of several sections like software configuration, hardware configuration, security, and access. Let's see each of them. We have to configure them. So for in the software section, we have to select the release, the version of your EMR cluster, also the applications inside it. So let's select the version which is latest. And now you can select the applications which you want. Like right now we are executing a Spark job. So I'm selecting a Spark. So which is nothing but Spark on Hadoop, which has Yarn and also Zeppelin. So make sure you have the similar version on on-premise if you are moving your workload from on-premise to cloud. So choose the version which is similar to here. Okay, let's go to the next one. So AWS Glue data catalog, which is used as a external Hive metastore for your Spark SQL jobs. So right now we are not using, so it will take the inbuilt one. Coming to the hardware configuration section, where you can define the instance type. So right now I'm running a job which is having less data. So let's select the one which is M3X large. So this will define your CPU and memory capabilities for your instances. So after that, you can define how many number of instances you wanted to run. If you select 3, it will run 1 master and 2 cores. You can select even 100. So it will run 1 master and 99 cores. So for our job, we are running only 3, 1 master and 2 core nodes. Cluster scaling, you can select this option if you want to scale your cluster according to the workload. You can define a maximum nodes you wanted to run and the minimum nodes. So in case if the workload grows, it will increase the nodes in your cluster and decrease the nodes accordingly. So right now we are not doing that. So you can uncheck it. Auto termination. So in case you forget your cluster to terminate after running the job, so this is the best option to choose. So it will auto terminate after some period of time you can specify here. So right now we are not doing that. So uncheck. Security and access. If you want to access your cluster using SSH, you can select this option and choose the key pair, the EC2 key pair, which is used to log in through SSH. I'm selecting the Spark key pair. And the permissions, when it comes to permissions, AWS will use the IAM roles to communicate with other resources in the AWS. So one role is EMR role, the other one is EC2 instance profile, which we need to create, these two roles. So EMR role will be useful to communicate with the CloudWatch and all. The EC2 instance profile role will be used to communicate with the S3 for writing and reading the data. These will be provided automatically by AWS, or you can even modify it if you want fine-grained permissions. So let's create the cluster, clicking on this create cluster button. So EMR cluster, when you start, it will take around 7 to 8 minutes to come up. So you can see the master node, it's provisioning, and the core node also it's provisioning. So now let's go back to the presentation. We'll go to the next step. So now we have spinned up the cluster. So let's go to the next step, which is pushing the files to S3. So before we doing this, I wanted to let you know the bucket structure we need to create. So to store any data in S3, first you have to create a bucket, and inside the bucket, you can create the folders to organize the data. So in our demo, what we'll be doing, we will be creating a S3 bucket called RemoteClazz EMR, which we already created when we are creating the log files. You can see in the bottom. This one we already created. So bucket is already exists. So for script, we will create a script folder. For input data, we'll create an input folder. For output data, output folder we will create. And we'll place the input file inside the input folder and script file inside the script folder. So now let's go back to the management console. Go to the S3 console. So we are here. So we already create the RemoteClazz EMR bucket. So let's create the folder structure inside this bucket. So first, let's create the script bucket. Create folder. And create the input folder. It'll ask the output folder. So be careful when you're creating an output folder. So your script, the job which runs, right, it will automatically create the output folder. So right now in my script, it is having a option of overwriting. So that's why I'm creating the output folder. If there is no overwrite, so please don't create the output folder. So now let's first copy the script file. So these files, we are going to share it using a GitHub location. So let's load the script here. Upload. And same with the input file. This is the input file which we are going to. This has 11 MB size. It will take some time. So when you're uploading the data to S3, there are multiple options to do this. So this is one of the way through the console, or you can use the APIs or SDKs to even the command line interface also to copy your data. So let's wait till it uploads. So uploading done. Let's close this part. Okay, and let's go back and see if our cluster is ready. Okay, some problem with the instance, it seems. the instance type. Okay, let's take another one. Let's quickly create. Oh, sorry, I've chosen the. Okay, to select the version and the application also, you have to select the proper one. So let's run info.x large. Choose the Spark keeper, create the cluster. So actually this error which occurred, right, basically it is trying to create these resources in US East 1F location. So in this, instance type is not supported, it's saying. So let's try this one, and one more also you can try. So actually, there is an advanced options also. What you can do is you can select the region in which you wanted to run the cluster resources. So select the Spark. And keep everything default. And here you can choose. Well, let's select US East 1. And keep everything normal. Auto termination remove. Next for debugging, you use the log folder. Click on next, and the EC2 pair, and create the cluster. So it will take around 7 to 8 minutes to spin up the resources. Meanwhile, we will see our slides, what we are going to do. So all these steps, right, we are going to run manually. So there is an automated task also. So right now, while spinning up the clusters, what happened, the instance types are not available in that particular availability zone. So that's why it is giving an error. So let's wait for the cluster to spin up. So after that, we will run a job on it and monitor the results using Spark history server, verify using Glue and Athena, and at the end terminate the cluster. So all these steps we can orchestrate as well. So what we can do is we can use a step functions. This is the architecture. So instead of running the cluster manually, what we'll be doing is we will be running a step functions. So step functions will make everything automated, and the event bridge we will use to trigger these step functions. So let's see how to do this. This also spin ups the cluster. So let's go to the EMR console. Type the step functions. Create a state machine. So I have already provided, we will be providing the location of these scripts into the GitHub location. So what we can do is we can directly copy paste that code here. So we'll discuss this once we spin up the cluster, because it will take some time to execute this. So you can see there is an execution here. It will create the EMR cluster, adds the step, and terminates the cluster. And at the end, it verifies the results using the glue. So let's click on next. Give it a proper name. Keep everything default. Create the state machine. So now our state machine is ready. So let's execute the state machine using event bridge. So event bridge is used to schedule the task, and also you can invoke event. Based on an event, you can invoke any service. So let's create. Give it a name, and the event pattern, it is scheduled. So you can schedule it hourly basis or days, or even cron style it will support. So right now, to execute immediately, I'll make it 1 minute. And you can choose the target which you wanted to execute, the step function state machine, and the state machine which we created. And you have to configure the input to it. So input is nothing but the job which you are going to run. So I have already have the input arguments for this. So let's copy this and create. So once you create this, if you go to the EMR service, it will start spinning up one server. Even you can go to the step functions to see if any execution starts here. Let's wait for 1 minute. You can see the execution has started. And let's see if cluster is spinning up. Yeah, you can see the cluster is spinning up now. Okay, so this way we can automate it. So basically, the clusters are still in the starting state. Not sure why it is taking time to do. Yeah, this one is coming up actually, bootstrapping. So let's understand the code here. The code which we are going to use for our job. So let me share the screen. So this is the input records which we are going to, the input file which we are going to use for our Spark job contains these records. It will have the number of columns like this. So basically it is a food inspection data where it will have an entry for a violation. So you'll have a violation type. So red or blue and the violation points and the name of the restaurant. So this data will be feeding it to the Spark job. So if you see the Spark job, it will create a session first and it gives a name to the app. After that, it reads the file. So the file which we are going to give it as an argument, first argument, input file. So after that, it creates a table on top of that file and you can run a SQL style of queries here. So we are querying for the top 10 restaurants with most red violations. At the end, all those results, we are writing it back to the S3 S3 bucket to the output folder, which we are sending it as a second argument. So let's see if our cluster is ready. So then we can run the job. Okay, the one cluster is ready. So actually you have to disable the event, otherwise it will keep on creating the clusters. So you can see one cluster is ready. So what we can do is we can terminate all of them. So go to this cluster and you have steps. Select the step, add the step here, choose Spark application, and you can choose the deployment mode, cluster or client, and you can even give the Spark submit options here. And then choose the location of your script. We have placed the script file in S3 bucket, which we created earlier. Select the script. And these two arguments, the input file and the output directory, which we need to copy it from the bucket. So let's go to the input folder, input file, copy the URI, paste it here, and then enter. And then go to the output directory. Copy the URI, enter it as a second argument. So after finishing the job, you can choose whether to terminate the cluster or continue. So you can add the step. Once you add, it will start executing. So before that, what I'm going to do is I wanted to see if our cluster, which we spinned up automatically, right? Is it coming up? Oh, no. Okay. Okay, let's submit the job now and wait till it gets finished. You can see it's in pending state. Let's wait for some more time. So you can even see the command which is executing on the cluster here. I hope this won't clash with the one which we executed here. So let us see. Okay, hopefully it's not. Let's wait till it's finished. Okay, now you can see the job is completed. Let's go to our S3 folder where we can see the output. You can see the output file is created here. You can download this file. And you can view the results in a notepad, or what we can do is we will run a Athena to query on this data. So let's go to the Athena console. Before that, we will create a glue catalog on top of it. Quickly create a glue catalog. Keep everything default and give your output folder location. RemoteClazz output folder. Everything next, and you have to create a role. Create the role, and we are running only on demand. So click next. Select the database where you want the schema, sample database. Click next, and then finish. So it will take 1 minute to execute this. So at the end, it will create a table here. So using that table, we can query it in Athena. So let's wait till the table creates. Meanwhile, we'll open the Athena screen. Go back and see. So meanwhile, we'll see how to monitor the job. So you have a tab called Application User Interface. So where you can use a Spark history server. Click on that. So remember that it will take 2 minutes. There will be a 2 minutes delay after your job completion. So it will spin up and show the job here. So let's wait till the application comes up. It's still taking the time. So let's wait. Yeah, you can see the history server will have our application which we ran. So here you can see the job which is completed, and you can even download the log files. So if you want more details, you can drill down and see the details as well. See the stages and executors and SQL. So likewise, we can run the Spark workloads. So crawler is still running. So okay, now it's stopped. Yep, you can see the table created here. So now let's go to the Athena and query here to see if the table is created. So now you can see the table created here. So let's run the query against the table. Yes, you can see the result here. So top 10 red violations, you can see it here. So let's go back to our slides. So till now, what we have done is creation of cluster and configuration, uploading the files to S3, running the Spark job, monitoring using Spark history server, verifying the results using Athena, and terminated. We will be terminating it now. Let's see. Go to the EMR cluster. Just click on that cluster and terminate. Okay. So let's see if our automation job, which we ran through the step execution, it's finished now completely. So you can see everything is success. As you know, right, the overwrite option is there in the script, so it will overwrite the data. So let's go back to our slides. So all these things, whatever manually we have done, we have scheduled it and orchestrated using step execution and event bridge. So with this, our demo is finished. So what we have learned how EMR service works and its architecture, its benefits, and how we can run Spark jobs on AWS Cloud. So we'll be sharing the GitHub location to you in the channel, so you can run it the Spark jobs on your AWS Cloud. So now we will open up for the Q&A. And let's see some questions. Sorry, actually the cluster had a problem. So in creating the resources in one of the availability zone. So because of that, it got delayed. So sorry for that. So let's look at this question here. Does AWS provide Jupyter Notebook environment which can integrate with EMR? Yes, actually it provides managed Jupyter Notebooks that you can do. So if you go to the console, you can see the Jupyter Notebooks here. So notebooks you can configure here. Can I add steps to a cluster that is already running? Yes, you can add the steps. So while creation of the cluster also you can do, and also after creating the cluster also you can do. Okay, with this, I'm handing over to Andre.
Right. So this is the end of the Vijay RemoteClazz. Say thanks to this guy in the comments below. Please like and share and subscribe for our Zenika TV YouTube channel, and see you in the next one. Hope you like the presentation, and that's it. Vijay can close the stream.
Yeah, thanks everyone for joining this session, and you can give us feedback on this social media, or even the email you can use to give us the feedback. Thank you so much for joining the session. I'm sorry for the interruption happened in the demo. I'm extremely sorry for that. Good night, everyone.